Assalamu alaikum. This is MATLAB course lecture number 2. In this lecture, we'll talk about how to define polynomials, how to do some operations on polynomials. We'll introduce also graphs, how you can use plot functions. And at the same time, we will learn how we can deal with data. Talk about the workspace data, how you can save these data, how you can load them, and so on. So let me open a new script file at the beginning. Again, just let me remind you that we can write codes on the command window line by line, but if we want to run a program, full program, or write script, full script, we have to open new script file. The difference that in the command line we can run line by line, one command each time, and see the result. In the script file we will write all of the code in one file, and then we will run the program once and then see the results. So it supposed that we open a new script, but let me start explaining things in the command window, then I will start new script and do some examples. Now, what is the polynomial? The polynomial, it's a function. It could be first degree, second degree, third degree function of x or y or z or s. The variable name, it could be any name. Now, to the right here we have an example: s to the power 4 plus 3s to the power 3 minus 15s to the power 2 minus 2s plus 9. This is a polynomial function with fourth degree. And how we can declare this polynomial in MATLAB? We can define it as a vector. Say that polynomial number 1, p1 equal. Now we have to open a bracket like this as a vector. Now we should start from the highest order, which is number 4 here, s to the power 4. The coefficient of s, it is 1. So we have to write 1, comma, or space. Then s to the power 3, we have 3. The coefficient is 3 here, followed by space or comma. Now s to the power 2, the coefficient is minus 15 like this, comma or space. S to the power 1, it is minus 2, and s to the power 0, coefficient is 9, or the constant is 9. Now, as you see, once I press enter, we have a polynomial vector p1. The coefficients are 1, 3, minus 15, minus 2, 9. This is how we can declare polynomial. Actually, for MATLAB, p1, it's a vector. The first element is 1, the second element is 3, minus 15, minus 2, 9. For us, as users, we need p1 to represent a polynomial. Now, it doesn't matter for MATLAB, is it polynomial or vector. At the end, it will be saved as a vector. As you see here, we have a p1 vector, double click. You can see all of the elements. It is 1 by 5 double, as you see. Let me close it again and go here. Now, how MATLAB will know that you need or you are working on polynomial once you use one of the built-in functions regarding polynomial or polynomial functions. As example, polyval, as you see here to the right, polyval function. It is a function used to evaluate a polynomial at a certain point. As example, let me say that I want to evaluate the p1. So I will write polyval. It's a built-in function, MATLAB function. I want to evaluate polynomial. Name is p1, comma, at 0. Now look to this polynomial. Now when s equal to 0, s to the power 4 will be 0, s to the power 3 will be 0, multiplied by 3 will be 0, this will be 0, here will be 0, and the final result will be 9. Let us check now what will be the result. As you see, answer equal 9. Now say that I want to evaluate the polynomial at x or s equal 1. So I will write again. I'm using the arrow, the upper arrowhead on the keyboard to repeat the last command. Then I will change 0 to 1. Then press enter. As you see, 1 to the power 4 is 1. 3 multiplied by 1 to the power 3, it is 1 plus 1. Sorry, 1 plus 3 will be 4. And here will be minus 15. 4 minus 15 will be minus 11. Minus 11 minus 2 will be minus 13. Minus 13 plus 9 will be minus 4. That's correct. CLC to clear the command line. Okay, now clear to clear the workspace. CLC again to clean the command window. Now as you see, s to the power 4 plus 1, how we can declare a variable or a vector containing the coefficients for this polynomial. We have to start writing v as example equal brackets like this, and then we should start from the largest power. Largest power here is s to the power 4, the coefficient is 1. S to the power 3 we don't have, so the coefficient will be 0. S to the power 2 coefficient will be 0. S to the power 1 we don't have, that means coefficient is 0. And last thing, the constant is 1, or the coefficient to 0 is 1. As you see, this is the polynomial. Again, this is a vector for MATLAB. Now polyval. Now polyval, I want to evaluate this polynomial, which is v, at 0. It should be 1. Yes. I want to evaluate this polynomial at minus 1. At minus 1. Minus 1 to the power 4 will be 1. Plus 1 will be 2. That's correct. CLC to clear the window. Now, can I evaluate the polynomial directly without defining the v? Let me clear the workspace to show you the example, and CLC. Then I will write polyval. I want to evaluate the polynomial. This is the polynomial. This is the polynomial. Which polynomial? I'm sorry, this is function. We have to write brackets like this. I want the polynomial to 1. Okay, I want to evaluate the polynomial. It was before I should write v, the variable name or the vector name or the polynomial name. But this time I will say that this is the vector represent the coefficients for each. Say that the coefficients for the polynomial. Let me go back to the first example, s to the power 4 plus 3, s to the power 3, and so on. So coefficients, they are 1, 3, again we have minus 15, followed by minus 2, and finally 9. Now no need to define this vector as a vector in the workspace. We can write like this directly. We get something like this. This is the result. The result answer equal minus 4. We can say that x equal now polyval again. Let me go back again. Where is polyval here? Never mind. Polyval. I have a polynomial function. This polynomial coefficients, they are 1, 1, 1, 1 as example, comma, I want to evaluate them at 1 or at minus 1. The result will be like this, x equals 0. So the result from the evaluation of the polynomial at minus 1 will be saved in x variable. CLC clear. CLC again. Now we have a roots function. Let me do again. Again, we can define a vector v equal like this, but I will write roots directly. So roots. Then I will write brackets for a function. I want the roots of the vector or the polynomial where first coefficient is 1, then followed by 3, same previous example. 3, then minus 15, then minus 2, and finally is 9. Now this is fourth order. This is fourth order polynomial. That means we have 4 roots. Once I press enter, the MATLAB will use the roots function to evaluate or find the roots of this polynomial or this vector. The answer, it is a vector with 4 values. Now if I want to say that r root as a variable, or say that are capital roots, because roots is a built-in function, and roots here it's just a word or variable name. Roots equal, now I'm using the roots function, built-in function. So this is just a variable name, R capital here. This is the built-in function. We want to evaluate all, find the roots for this polynomial. Now enter, I see roots. Now I want to find or use the first root. So I will write roots of 1. See, this is the first root. Next, we have a conv function. It is a function for polynomials used to multiply two polynomials and find the result. The result will be a vector also, represent the multiplication. So say that we have already say that v1 equal, as example, as seen in this example, 1 and 2. Just to remind you what meant by 1 and 2, that means here we have just two coefficients. That means it is a first order polynomial, so the highest power it is 1. So let me go to whiteboard and convert this one to a polynomial, just to show you the polynomial, what it is. So in the whiteboard, now the first coefficient is 1. It should be 1 multiplied by x to the power 1 plus 2. This is the function or polynomial. That means it is x plus 2. This is my polynomial. Let me go back to here. The second polynomial, it is 1, 4, 8. So let me run this code. The second polynomial say that v2 equal to 1, 4, 1, 4, 8. Now let me convert it to a polynomial again. So the first one, it is x. The first polynomial will be x plus 1. The second one, as you see, the first coefficient is 1. So we have three coefficients. That means we have say that the second order polynomial, because it will be 1 multiplied by x to the power 2 plus 4 multiplied by x to the power 1 plus 8. So the second one, it is x to the power 2 plus 4x plus 8. So we have v1 and I'm sorry, by mistake I wrote v1. So let me repeat the code for v1 and write this one v2, no problem. This one should be v2 like this. Enter. So I have v1 in the workspace and I have v2. Let me clear the command window like this. Now I want to produce or find the product of v1 multiplied by v2. By the way, it doesn't matter v1 multiplied by v2 or v2 multiplied by v1, same result. So now I will write conv function, conv. I want the conv of v1 comma v2. I want the product of v1 and v2. The result will be a vector with 1, 2, 3, 4, 5 coefficients. Now the result is as the following. I will show you the result. Just let me move this one here like this, okay, and show you the result of multiplication. It is 1. We have 4 coefficients. That means x to the power 3. So it is x to the power 3. 1 by x to the power 3 will be x to the power 3 plus 6x to the power 2 plus 16x plus 16. This is the result, the final result using the MATLAB. Now let me show you how we can multiply using manual. So x to the, multiplied by x to the power 2 will be x to the power 3. Let me change the color, okay, because this is manual. This is manual multiplication. I will do it by myself. So x by x to the power 2 will be x to the power 3 plus, next x multiplied by 4x, it will be 4 x squared plus now x multiplied by 8 will be 8x plus now 1 multiplied by x to the power 2, it will be x to the power 2 plus 1 4x plus 8. Now take it is x to the power 3, this one done, it will be x to the power 3. So for this one it's okay. Now let me take x to the power 2, we have 1 and 4, we have 5 here. Again x to the power 2 and 4, x to the power 2, we have 5x to the power 2. Again there is a mistake, x again, let me repeat, x multiplied by x to the power 2 x3, x multiplied by 4x, it is again 4x to the power 2, and x multiplied by 8 8x, then 1 x2, it will be x2, 1 multiplied by 4x, it is 4x, 1 by 8, it is 8, and then x to the power 2 plus again 4x to the power 2 and x to the power 2, this one and this one will be 5x2 to the power 2 plus now 8x and 4x, it will be 12 x, it will be 12x plus 12x plus again 8, here we have 8 and we forgot something maybe. Yes, it's just 8. It is just 8. But why we got something different? Let me check again. The first one here, v1, it was how much? It is 1 4 8. 1, this is 1, this is 4, this is 8. The second it's 1 2. Oh my god, this is the mistake. It is 1 2. That means x plus 2. This is the mistake, guys. Okay, I will change it, this one to 2, and do it again. Okay, do again, just to show you. This is 2. Now the first 1 2 3 terms, it was correct, and now next one, it is x multiply, sorry, 2. The last 3 should be modified. 2 multiplied by x to the power 2, here it will be 2. So I will change it, this one, it will be 2, 2x to the power 2, followed by 8x, followed by 8. This should be 8x, followed by 16, and this one should be 16. 16, now we get now x to the power 3 same, 4 plus 2 will be 6, so this one will be 6. This one will be 6 to x to the power 2 plus here we have 2 x to the power, sorry, 8x, and 8x will be 16, will be 16x, will be 16x plus 16, and this is the 16. So the result will be like this. This is a very good example. As you see, if I want to do it manually, it needs some mathematical calculations, and maybe one mistake, it will give you a wrong answer. Imagine that this is part of algorithm or a program you are sorry, part of algorithm, you want to find a result, then you will get a wrong result. But using MATLAB, you will get it efficiently, correctly. So I see 1 6, the coefficient here, it is 1, it is 1, and here it is 6, here it is 16, and here it is 16 also. So 1 6 16 16. Okay, CLC. Now another function, derivative. How you can find the derivative of polynomial? We have a built-in function called ployder. We can use it in two forms. So as example, I have v1. Let me show you the v1. The v1, it is, let me write the example. The v1 here, it is 1 4 8. That means it is x to the power 2 plus 4x plus 9 or 8. Okay, now the derivative will be 2 to the power x, 2 minus 1 will be 1, plus 4x to the power 0, which is 4, and derivative of the constant will be 0. So we will get a result, a vector like 2 and 4, a new vector, a new polynomial with coefficients 2 and 4. And let us do it in MATLAB. We will use the ployder function. So I will use the polyder. I need the polynomial derivative. Which polynomial? V1 polynomial. I should get 2 and 4. A new vector, the answer is 2 and 4. I can write it also polyder. I want the polynomial derivative for a polynomial. We can write like this. It is 1, 4, 1, 4, and 8 like this. We'll get the same results. Now I will do the polyder of polyder. So polyder of the polyder of the V1. I should get just 2. Undefined function or variable polyder. Okay, there's a mistake here, so it's poly y here. Very good. So I will get 2. Why? Because the derivative of this function, it is 2 plus 0, which is 2. Now say that I want to evaluate or find the derivative of multiplication of 2 variables or 2 polynomials. Say that V1 and V2. We can find polyder, or right, so not find, right, polyder V1 comma V2. That means I want the derivative of the multiplication. Just to show you, if you remember the multiplication, or let me do it. First of all, let me write conv. I will show you conv of V1 and V2. This is 1, 16, 6, 16, 6. Now polyder of V1 multiplied by V2. This is the result. Let us check the result by ourselves. Now again, say that I have, again, we said that V1, it is x to the power 2, x to the power 2 plus 4x plus 8 multiply by 1, 2, which is x plus 2. Okay, the result of this one, it should be, as I told you, it will be x to the power 3 plus 66, x to the power 2 plus 16x plus 16. Okay, now I want to take the derivative of this one. So the derivative is 3x to the power 2 plus 2 multiplied by 6, 12x plus 16 plus 0. So as you see, the vector represent this polynomial. It is 3, 12, 16. And this is what we got in MATLAB, using MATLAB. Say that I want to evaluate the derivative. So we can say that polyval, I want to evaluate the derivative. Which derivative? It is a polyder of what? Of the vector V1. Okay, at which point? Say that at -1. See the result, the answer is 2. How this comes, I will show you. Now what is the polynomial? It is 1, 4, 8. That means it is x to the power 2. The polynomial is x to the power 2 plus 4x plus 8. The derivative will be 2x plus 4. Now apply this function at -1. It will be -2 plus 4. The result will be 2. So this is how MATLAB or how we can use the polyval to evaluate the derivative. Now it should be like this, polyval, polyder. It's okay. We can say that derivative dr, a variable called der equal poly polyder of the vector, and this vector is v1. We got it like this. Then polyval the derivative which is there at point -1, we'll get the same result too. Now let us talk about how we can use graphs in MATLAB, how we can plot. We have a built-in function called plot. If we write here help plot, it will show us summary about the plot, how we can use the plot with examples. So as you see here, we have plot function, linear plot. We can use some alphabet here. B to say that the plot color is blue, G for green, R for red, C for cyan, and M for magenta, Y for yellow, K for black, W for white. And the type of plot, we can use it as a dot to present points, or O as a circle, or X mark, plus mark, star mark, S, D, and so on. S for square, D for diamond, V for triangle down, this one triangle up, the triangle left, triangle. We have many things we can use. We can use this one as a solid, but if you remove the alphabet or the option, it will be by default solid. You double dot, you can use this one or that one, it's up to you. And here we have different plots, how we can use it. So the help will give you complete idea about the function and how we can use it. Now let me show you examples. Say that I want to evaluate the vector v1, or say that I have a new variable called x in x-axis, or t, whatever the name. X, it is as example a vector from 1 to 10, from 1 to 10 like this, and we need y equal x dot to the power 2. So it is a polynomial, second degree polynomial. Now I have the value of x, I have the value of y. I will show you first of all, I will plot x individually like this. It will plot the x values. So in the x direction, we have the index of each, as you see in x direction here, we have in x direction we have the index of each value in x, and in y direction we have the corresponding x value. So it will print or plot the x as it is. Now I want to plot x versus y, or y versus x. So I plot x in x direction, y in y direction. We will get a graph like this, and this is the representation of the polynomial, second degree polynomial. Now say that I want to show in this figure number 1, I want to show the title of the figure. I will close. Actually, to do that, we have to say that I will copy all of these commands together, Ctrl C, and then I will go to new script file. Before that, let me clear the workspace and clear the command window like this. Now I will write CLC clear close all to close all figures, previous figures, and now I will paste the code like this. Okay, write semicolon. I don't want to see the result, but this is not for the plot, for these commands. Let me delete the plot x. I want to plot x like this. Let me run the program to show you the result again. Save the file as m file. Okay, anything.m, never mind. Now as you see, this is the result. I want to show a title. What I will do, guys, before the plot, I will use the hold on to hold all components in one figure. So hold on to keep a same graph in plot. So I plot x, y followed by the title. So I will use a built-in function called title. Okay, it's a built-in function. It accepts a string in MATLAB within 2 single quotation, not in like C double quotation. We can say that example, plot example. Okay, let me run the code and show you. See here, plot example. Now say that I want to put a label for x. We can write x label. We have a built-in function called label. Same thing, this function accept a string. Don't use double quotation. For MATLAB, single quotation like this. We can write x, x, and same thing for y. Control C, Control V. We can write here y label, name it y or heat or whatever. It depends on the example you have. Run the program. As you see, we have here the title is plot, the name in the y direction it is y, the name in x direction it is x. Say that we want a grid for this graph, we can use grid on. We can say grid on. Run the program again. See, we have same graph but with grid. As example, I want to zoom or focus on certain range in x and y. We can say that axis like this. This function accept a vector show what are the values in x direction. I want to show just between 3 and 7, and the corresponding values in y. So let me show just x axis. Run the program. We have a mistake because this, we have to add the y range. If you remember here, for 3 the y approximately 10, and for the 7 the y approximately is 50. So say that between 0 and 60, 0 and 60. So 0 and 60. So this is the range I want. Run the program again. As you see, we have just between 3 and 7 in x-axis and 0 and 60 in y-axis to make zoom in or zoom out in the graph or focus on a certain range. Now, what about the way of the graph? Let me remove the axis, this one. I keep the grid and go to plot. Now I want to plot in yellow color. We can single quotation like this, write yellow. Run the program. As you see, it is yellow. Let me again change it to G as a green. Run the program, it will become in green. Let me write R here, it will become red. What about the type, comma, and the type here again, the type will be star. It will print, by the way, I will show you. Let me run the program here. We got something wrong because we should not, again, there is something wrong. So I will write help again, help, and then write plot to see how we can plot the color and the line type at the same time. See, we have to write plot. This is the line type. Okay, I think it's correct. I don't know why it gives me an error. So let me check again. By the way, in MATLAB you should not remember everything because you have a help. So if you have a doubt or have a problem, you can check the MATLAB always. It says that error in this line, invalid data argument in the plot. Again, we have something wrong in the plot. Okay. Again, as I told you, you should not remember everything. I just remember that we have to keep them in one argument like this. R for a red, then space, a star as a star. Run the program again. Okay, as you see, we have points plotted as a point, not a continuous line. By the way, if you use line type as a star or rectangle or whatever, you are plotting a discrete function. If you remove the star like this, you are plotting a continuous function like this. Now let me try to plot x or y as a bar graph. So I will use bar built-in function, then brackets, then I will say that I want to plot y, and we'll see the result. As you see, this is the result. We are plotting y as a bar graph. As you see here, index number 1, the value around 0, index number 2 in y, the value around 5, index number 3, the height will be 10, and so on. And we can change the color of the bars and everything. So let me write again bar like this and say that I want it in green as example. Plot, as you see, have green. And if you want more help about bar, just like help, just write help bar like this, and you can see here what options we have in MATLAB for the bar. Here are the options how we can deal with bar graph plots. Now CLC again. We talked about how we can plot one variable or plot two variables, x versus y or y versus x, or three sometimes. Also we can, if we have if you want a 3D plot, we can use it in MATLAB also. Later I will show you inshallah in next lectures how we can plot them. Regarding the axes, we talked about axes, label and title, grade, hold on, hold off. By the way, as you see here we have hold on. It's better if you wish or you want to start a new graph later to plot two graphs, you can write hold off, not two graphs, sorry, because once you run the program the current plot will delete the old plot because we don't have hold on yet. So keep it or remove it, it depends. Now let us talk about how we can save data in the workspace, save data of the workspace in the current folder to load them later. Say that as example you have an algorithm and you write the code and you run the code, and the code it needs time to run, and you have the result in the workspace and you want to take these results and deal with it or analyze it or do something later. So I want to keep the results again in my current folder so I can use them again and again without running the program. So after finishing everything we can write save. Save, it's a built-in function used to save the data in the workspace. Up to now we have just x and y, so we can save, give it a name, say my data, okay, number one or data one, it's up to you, the name, just the name, data one dot mat as a MATLAB data like this. Then you can clear the workspace as you see, and so on. So clear, it will clear the workspace. After running this program we will not see the data in the workspace, we will see them just a file saved in the current folder. Run the program to see we have this graph as you see, the workspace cleared, but look to the current folder we have a mat file, the name is data.1. Now say that I want to do something with this data, we can later, before running the program, if you want to say that I want to analyze data, Ctrl C, I will open new program, Ctrl V. At the beginning I have to load them, so load, we can write load, the name of the file it is data1, extension is .mat. I will show you what will happen now. See the workspace now it's empty. Run the program, it will, okay, save the file, it's okay. Again change the name, I have the same name, okay. Now see we have x and we have y in the workspace because x and y saved as a data1.mat, and we should load the data, or we should already loaded the data here. Then we can say plot as example, plot x comma y as we discussed before. See I have the plot, okay. So this is how we can save and load all of the data of the workspace. Say that, let me go to the command line here and work on command line. As example, let me delete this one, this file, or close it. As example, I want to save x alone. So we can write save, say x data dot mat, this is the file name, then space x, that means go to workspace, just save the vector x in the xdata.mat. As you see here we have xdata.mat, and I will do the same thing for y. I will repeat the same code but write here y data as a file name. As you see, I'm sorry, this is by mistake. I will repeat again, and I have to write here y because I want to save y in the y data. Now the file here updated. We have x data, y data. Now let me clear the workspace CLC. As you see, the workspace is we don't have x and y. Say that I want to plot x versus y or y versus x. Say that x comma y, undefined function of variable x and y. So we don't have data in the workspace as you see here, but we can load the file called xdata.mat. Enter. Now we have the value of the x. Then I will load also y data.mat. Okay, I have them. Very good. Now we can make a plot of x and y, so that x in x-axis, y in y-axis. This is the plot we got. Again, CLC. Okay, let me delete this file. Okay, delete this file by press on the file delete or right click. Load. We can load by right click. By the way, we can just right click on this file, load. See, the file loaded. Let me delete it from here. We can rename it, and this, let me delete this data also. Okay, CLC. And now I have let me say that I want to save data.mat everything. So my data now, we have x and y inside this data. Now let me CLC clear the workspace, CLC again. Now I will load x only from that file. Load say data.mat, load just x. I want to load just x from that file. See, the y will not be loaded. If you want to load all things, just repeat the code and delete the x, enter. It will load x and y. Then you can perform some actions or do some action, do something regarding y and x, like lot. Now let me talk about, we talked about, if you remember, the polynomial derivative. What about the derivative of a function, not a polynomial, any function like log, like exponential or whatever? How we can make multiplication, or find the derivative? Let me open new script. As I told you, we should start by this. So copy the code, paste it here. And now say that I have a function like this function. The function is sine 5x. So we have to use the symbolic way. So symbolic variable or symbolic equation. So we have to write syms, system of symbolic equation. The variable here name is x. As example, you can name it z, you can name it s, depends. Now the function name is f. You can name it any name. Equals sine 5 multiply by x, like this, and then semicolon. Now we have f as a symbolic function. Now we want to differentiate. We have a built-in function called diff. I will use the differentiation of f. Then we will get the result. I will run the program, show you the result. The result is a symbolic equation also. So save it as m, anything else. Then run the program. It will find the derivative now and return the value. See, the answer is 5 cosine 5 multiplied by x. If you remember differentiation, it will be 5 because the 5 coefficient of x will be outside, and the derivative of sine will be cosine. So it will be 5 cosine 5x. Now, how we can differentiate at certain point? This is general differentiation. Now, say that I will repeat the same thing. Let me select the same. So I will say that I want the diff, or here, let me write it here, comma, I want the derivative of f at the point evaluated at point, say that 1. If you remember, it is, or say not 1, say 1, it's okay. Remember that it's 5 cosine 5x, x equal 1 multiplied by 5, 5 cosine 5 multiplied by 5. And let me delete this one. Now run the program. We will get the result. It should be a number. No, sorry, this is the derivative at 1. Derivative at 1. I'm sorry guys. Again, I told you sometimes we forgot what it is, the function, how it works. Again, this is f1, that means the first derivative. I'm sorry, not differentiate if at 1, I'm sorry. This should be, if it's 2, the second derivative. If it's 3, will be the third derivative, and so on. Now, if you remember the first derivative, it was 5 cosine 5x. Now, what is the second derivative of the same function? It will be derivative of this one. That means, again, 5 multiplied by 5, it will be 25. The derivative of cosine, it will be minus sine. So we'll get minus 25 sine 5x. Run the program again. See the result, minus 25 sine 5x. Again, I'm sorry again for this mistake. When you write diff f to 2, that means second derivative. If you want the third derivative, you write 3. Fourth, write 4, and so on. What about if you want the derivative of second derivative at 2 or at 1? Want to evaluate it or evaluate the function itself? By the way, say that let me run the program here, run the code here. We can say that I want f of say that 2. F of 2 index exceeds the number of array. That means because, okay, let me run the program. Let me not run, write it here. Say that as example, g equal f of 2. And let me run the program. We have the same error. Actually, I forgot exactly how we can evaluate the derivative. Just give me seconds. I will remember, inshallah, how we can do it. Now let me read the code again. Syms x f equal 5x. Oh, I remember now. Okay, it's okay. If it is a function and you want to evaluate it, it's better to write f of x. To evaluate the function, I think it's better to write syms f of x, and the value of f of x, say that f of x equals sine 5x, like this. And now we can say that f of 2 differentiate f, second derivative of f. Run the program to show, as you see, the answer of the first one, f of 2, it is sine 10x, while the derivative, second derivative of the function equal minus 25 sine 5x. Again, it's better to write it like this, symbolic syms f of x equals sine of 5 multiplied by x, then f of 2 to evaluate the function f at the point x equal 2, and so on. Now let us start solving the exercises. Exercise number 1. Write a program to do the following for function f of x equal x to the power 4 minus x to the power 2 plus 2. For x, the range of x will be from minus 10 to 10. Find the roots of this function. It's polynomial function. So it says that write a program, and we have many steps. So let me go and open a new script file. Start by CLC followed by clear. This is must always close all. Okay, then I have to find the root, so we can use a comment percentage, say that part 1. For the part 1, find the roots of the function. Say that the roots are t, vector equal, we can say that roots of the vector, we can write the vector like this. The vector, it's x to the power 4, the coefficient is 1, the maximum power here it's 4. Then for 3, the power of 3, it will be 0, there is no x to the power 3. Then minus 1 followed by 2. Now semicolon, I don't want to see the results. Okay, can I write it in different way? Yes, we can say that I have the polynomial p equal to this one. Cut this one, cut all of the vector from here, put it here, and then semicolon. I don't want to see the result in the command window. Say rt equal roots of p. It's up to you. Okay, run the program. As you see, name it as lecture number 2 exercise 1.matlab. Okay, now run the program. Run the program again. Now as you see, we have the p, it's the polynomial, the roots. Now let me show you the roots. RT enter. We have 3 roots. Why? Because it's power 3. We have 4 coefficients. The maximum power is 3 here. It's x to the power 3 minus x plus 2. So we have 3 roots, and they are not real roots, they are imaginary roots. In MATLAB it can show you the imaginary roots when you have a square root of negative number. Next part, evaluate the function at x equal 1.5. Evaluate the function, so we have to use the polyval. So let me say that evaluation EV, the point is 1.5, say 1.5 like this, EV 1.5, okay, equal evaluate, sorry, polyval, the polynomial p at 1.5, then semicolon. Now let me run the program. Before that, as you see here, we have underline error. We have red line here. That means we have error. It says that pairs error at 0.5. We can't use this name with dot. Say that 1.5 as this, and then evaluate it. Run the program again. It's correct. We have the, as you see, EV 1.5. It's 3.8750. If I want to show, we can display, use the display function disp. I want to display the value of EV15 like this. Run the program. I see display here. Can I use the print function like in C program? Yes, we can use print, but the function here it's f print f function, print function like this. I want, if you remember, we have the message here. The message should be between it should be a string between 2 double quotation in C, but in MATLAB we will use single quotation. Now we can say that function evaluation, function value at 1.5 is, and here we have to reserve, I'm sorry, again is, we have to reserve a float or double LF because the percentage LF because it's double in MATLAB. And then we can go to next line, \n like this. Outside again, same like C. Outside here we have to put the variable name. The variable name is EV15 like this. Run the program. As you see, function value at 1.5 is it should be the value of EV15. So I don't know, maybe we remove this one. Again, yes, we should use f. Okay, never mind. Now again, CLC, run the program again. I see the function value at 1.5 is 3.875000, and then go to the next line like this. It's okay. Now CLC. Next step, part number. Sorry, we forgot to write a comment. Control C. This is the roots. This is the part number 2. And let me write a comment here. Part number 3. Again, evaluate the function. Sorry, plot the function. Use increment of 0.1 to plot the function. Remember that the function, it's a polynomial function. The range of x, it is from -10 to 10. So we have to create a vector. Say that t equal from -10 to 10. But I don't show me the result in the command window, but the increment, it should be 0.5. The increment is 0.1, sorry, so 0.1 like this. Let me evaluate it to show you the result of the t. Evaluate and go to here, t. See, this is the t. It is from -10 to 10 incremented by 1. Close it again and go here. Next, I want to plot the function. So I want to evaluate, first of all, say that y equal polyval. I want to evaluate the polynomial. Which polynomial? P. At which point? Each point in t. each point in T to get a new vector. So let me evaluate this vector, show you the result. Evaluate, we will get same size, 1 by 21 y value. So this is the function, the polynomial evaluation at x equal minus 10, and the last one for 10. So now we can use the plot. So let me plot. So plot. Now I want to plot t in the x direction and y in y direction. We can choose the color to be red or blue with a star as example. Now this function, it's polynomial, continuous function. We should not use a star. I think it's better to remove a star, but to show you example, run the program, see the result. Again, we should remove the star because it's continuous function here, not discrete. So run the program, we get something like this. Say that I want to change the width of this line. Just to remember, we have to say help plot. Now let me go to how we can, yes, this is the how we can use it. Line width, comma 2, Control C. We can say CLC now and go back to the program, write comma here, and then paste the code. We have to use the line width option. The width is 2. You can change it to 1.5, 2, 3, any value. Run the program again. See, the line width changed. And we have the result function value at 1.5 like this. Now let me copy the comment again. Control C, Control V here, part number 4. For the part number 4, it says that show plot the roots and x equal 1.5 at same previous figure using star with red color. Hint, use the polyval, polyder, and roots function. Now we have to find the roots. Again, the roots, they are saved in the say that vector. Now let me evaluate the roots. The evaluation, just to show you, let me evaluate the roots. The result should be all zeros. So say polyval. I want to evaluate the polynomial p at roots rt. We should get zeros. Actually, this is near 0. Okay, the answers are zeros. I will show you in the graph. CLC. I will repeat here, guys. So again, just to remind you, we need the evaluation. Say evaluation of RT equal polyval. I want to evaluate the polynomial P at the all points RT. Don't show me the result in the command window. Now I want to plot. I want to plot in x-axis. I want to plot the values of roots, say RT, and the corresponding values of the evaluation. It should be zeros all, but let me write evaluation of the polynomial RT. The name of the variable is EVRT, like this, and let me print them as a star. Say that green star, like this, green star. And because I have more than one plot here at the same graph or same figure, it's better to write here after the close all, hold on. Run the program. See, we have warning here, but it's okay. See, we have, see, this is the original graph, and these are the zeros. See, the values are near 0. Why where are the others? There are 2 points here and 2 points here, I think, or I don't know. We have a warning here. The third root may be duplicated here or somewhere else, or in between. But let me read the warning. It says that imaginary parts of complex x and y arguments ignored. That means they take just the real parts. So we have for the real parts, go to the RT 1.5214. Okay, let me open the RT, the roots. See, we have 1, 2, 3. But the imaginary parts will be ignored. That means, see, we have duplication here. We have this point and this point, same value. This is why we saw in the graph just two zeros, because here approximately here. I think we have two roots here or there. We have two roots, same value. Close it. CLC. We use the polyval, polyder, and roots. Now show plot the roots and x equal 1.5 at the same previous figure using star with red color. We change it to red color, not the green. This should be R. And we have to plot x equal 1.5. So again, plot here, plot the value 1.5 in x direction, and its value, if you remember, we evaluated the polynomial at 1.5 and the name is AEV15. Print it or plot it 1.5 with EV15 like this. Run the program to show you the result. As you see, we have here again same story, but where is the 1.5? 1.5, it's here approximately. Yes, this is 1.5. Here we have 1.5. No, not 1.5. Here should be 1.5. I don't know. Let me we have hold on here again, and again plot the roots and plot 1.5 at EV15. At EV15 it's 3.87. 3.87. Let me run again. 3.7. So 1.5 and 3.7, it should be somewhere here. Hold on, it's correct. Hold on, plot this one, plot this one. I forgot to change the color. I'm sorry. We have to change the color here. We should use red with a star because it was a default color. We will not distinguish it. Run the program again. See, this is the 1.5 approximately here. Okay. If you want to put the title, x title, y title, sorry, x label, y label, and title and the grid, you can show the grid like this. Grid on, and run the program, because remember that all of these components, the original plot and these plots and the grid, will be shown in the figure if you use the hold on. The hold on means keep the same figure while you are plotting this one and this one and this one, and run this one also. So this is exercise number 1 finished. I don't know why written here polyder. Maybe I changed the question. It's okay, never mind. Question number 2, it says that write a program, MATLAB program, do the following for the function. We have a function, but this is not a polynomial function. Okay, so again, CLC, clear, close all. Then now we want to evaluate the function at x equal pi over 2. Here we don't have a polynomial function, so we will use syms function f of say that f of x, and then we can write f of x equal to, or g of x, sorry, because it, as written in the question, it's g of x equal to sine x to the power 2, this is x to the power 2, which is x multiplied by x, then outside minus log of x, like this. Okay, next the first part. So let me write a comment here, say part number 1. I want to evaluate the g at x equal pi over 2. Just to remind you, if you remember in C programming, the sine function, it takes the value of the angle in radian by default. So if you want it as in degree, you have to convert in degree. Or sorry, if you want to read the value of the angle from the user input as degrees, you have to convert it to radian, then use it in this equation. In MATLAB, we have function called sine d. if this angle in degrees, just write sine d, not in degrees and radians, remove it, so no need to convert. So sine x to the power x log s. Now the first part, we want to evaluate the g. Say that value or g value equal g of the pi over 2. We can write 3.14 divided by 2, or use the built-in value pi. Okay, let me run the program to show you the result. Say that this is lecture number 2, exercise number 2 .matlab.m. See the value here, it is sine of pi to the power 2 over 4 minus log. Okay, say g value again, g value, enter, I'm sorry, not here, CLC, write g value to show it again. This is the value. Okay, now I don't want to see the result here, or see it, doesn't matter. If you want to show it printed, you can use the print or display function, it's up to you. So you can delete it like this, and then use the display function disp, and inside display just write the g value like this. Run to see the result, as you see. Next part, find the function f of x that equal to the derivative of g of x. So part 2, we want to use the derivative, so we can write derivative of g, there g equal, or say f, I'm sorry, f of x equal to diff, it is the first or second derivative written in question, the first derivative, so diff of g. Now let me run the program. It says that here, terminate the statement, show it, no problem. Run the program, see this is the derivative. Okay, we can terminate now, no problem. The third one, it is evaluate the function f at x. Same story, percentage part number 3, but I want to evaluate it, so we can write here f value equal, as example, f of how much, pi over 2, write pi over 2 like this. We can say that pi equal 3.14 at the beginning, never mind. Okay, run the program, see the result. Okay, next step, number 4, plot function g and f using the increment 0.1 and show the corresponding points for x equal pi over 2. Remember that the values of x should be between 1 and 2 pi. So for the part number 4, sorry, we have to write, anyway, double click here, right click, comment. Okay, now we want to define the x value. Say that x equal from 1 to 2 pi, 2 multiply pi like this. Okay, I don't want to see the result. Incremented by how much? The increment as written in the question, it is 0.1. So here should be 0.1. It will create a vector. The name of the vector is x. Start from 1, end by 2 pi, incremented by 0.1. We have the value of x. Now let me evaluate. Say that g value at x equal g of x Remember that x here, it is a vector now, or we can, if you want to distinguish between this x and this x, doesn't matter, but say t, it's better, never mind. G of t like this. I don't want to see the result. And same thing we can write here. We can copy the code, Control C, Control V. Now we need the f value at each t, change this one to t better, also equal f of t. Now we have them. Let me run the program to see that we have the result. It's okay. Look to the g value of t, f value of t, we have it. Okay, now we want to plot. We want to plot first of all. So hold on, better to keep. So hold on. I want to keep both plots in one figure. So I will use plot in x-axis. I want all of the values of t. In y-axis, at the beginning I want the g values. Say g value t like this. Say that I want it as in red, and I will repeat the code again for the second one. So let me copy the code, Control C, Control V, but here should be f value, the derivative value of g at each t, and say this is in green. Let me run and see what will happen. So I'll see we have, this is the red one, it is the function itself, and see the derivative, it is the green one. See that the function, or it's we have some here not fully curved. We have some lines here because the or say that accuracy of plotting is not good because the increment, it's a little bit large. So we can go to the increment, make it 0.01 like this, and repeat the plot. You will get something like this. It's more clear, as you see, more smooth. Okay. But now we need also to plot the values of the f, and g at x equal pi over 2. So we can also here write, say that g value at pi over 2, pi 2, say that pi 2, we can say that 2 equal g of pi over 2, okay. And same thing for the f, Control C, Control V. We can say that f value at pi over 2 equal f of pi over 2. Run the program. We have the values. Now we want to plot again. We want to plot at x-axis the pi over 2 itself, pi over 2. At y-axis the value, f value. We'll start g value 2. Say that in blue stars like this, and I will repeat it for the second point, which is for the derivative. Plot pi over 2 f value, the derivative value at pi over 2 like this. Run the program to see the result. Now as you see, this is the original function, this is the value of pi over 2 of that function, and this is the derivative, and this is the value of the derivative at at pi over 2. Actually here we have subs. Actually this subs I will show you. CLC, write subs. Subs means substitute. If you want to substitute, I forgot to write help subs. Okay, as you see, substitute. That means if you have a simple equation and you want to evaluate the function at this value, so use subs. So what I will do in this case, I will keep the same program, but I will go to here. See, write symbolic at x here, and here we can write g equal sign. Now g value equal subs. I will write subs. I want to substitute. Okay, I want to substitute the function called g at pi over 2. then display the value. Same thing, we can write f equal differentiate of g, then f value equal same subs. I want to substitute the function f at pi over 2 like this, and so on. Here we can say that g value at t equal substitute of g at each t value, f value same thing, subs of f at each t value, and keep here same thing here, g value at 2 equal again subs of g at pi over 2, and here same thing, substitute f at pi over 2, and plot them same thing. Run the program, we will get the same plot and same results. Okay, so you can use it like this by using syms at x, then g equal, then use the subs to evaluate the function at a certain point or more than one point. It's up to you, or use it as I did before. It's up to you. Both of them works well, never mind. So I finished the second class or exercise, classwork exercise. Now let me go to exercise number 3. Again, I will write CLC clear close all. Then it says that simple harmonic motion is typified by the motion of mass on a spring. The motion is sinusoidal in time. Using subplot, I will use a new function here, plot the response of the system for k values of 100, 300, 500. Take a equal 10, m equal, so let me write here a equal 10. The value is a equal 10. I don't want to see the result. We can keep them in one line, it's up to you. M equal to 1 semicolon, and say that te from 0 to 100 seconds. We can define the variable t from 1 or from 0 to 100 like this, t function or t vector, and now we want to do it for k equal 100, 300, 500. Don't forget labels and title, and we want to plot the response like this using subplot. That means we have 3 different plots. I will do it in different ways. Okay, I will do it now as example. I will say that k1 equal 100, so 100 like this, and then I will write the function y, so we can say that y equal the a value multiplied by sine omega t, or sine the square root sqrt. It's a built-in function to calculate the square root of k over m, k divided by m, and the final result, so outside the square root multiplied by the t. Now this is a constant multiplied by vector, no need for dot, it's okay. Okay, let me run the program to see. We have, say that this is lecture 2 exercise 3.m. Now see, we have a, we have k1 m t, it's 1 by 100 double values vector. Okay, now we have the say that y1, it's better y1 to distinguish. Okay, we can repeat same story, control C, control V. You can write k2 equal 300, and y2 equal same thing. Here here we have k1, and here we have k2. Okay, and then control V, k3 equal 500, y3 equal K3 here. Okay, now run the program. We got the results without errors. It's okay. So we have IC1, Y1, Y2, Y3. It's 1 by 100 double values vectors. Now we want to plot without subplot. If you remember, we have to hold on and then plot as you see. I will show you plot. We can say that plot t, okay, t with y1, okay, comma in red. Then we can say that plot t with y2 in green, and we can say that plot t with y3 in one line, y3, say that blue. Let me show you the result. Run the program. See all of the plots in one figure, but I can't distinguish anything. So it's better, guys, to do what? To split them in, say that we want one figure, but split the plots by using subplot function. So what I will do, I will remove the hold on, no need for it. Now I will use subplot. So I will write subplot. In the subplot, now the plot, it will be like a matrix plot, or say that array of plots. Say that how many rows we have. Say that I want 3 rows, 1 column, the first plot, and then I will plot. I will say Control C. I will remove all of these and keep it just one plot like this. Then I will do the same thing. Control C, Control V. Plot number 2, subplot 3 by 1. Plot number 2, the second plot. I will plot T with Y2, and I will do the same thing for the last one. Subplot 3 by 1, the third plot. Plot T with Y3, as you see here. Now let me run the program to show you the result. As you see, we have 3 different plots in one figure. Okay, let me change the color, green, blue. Okay, run again. Okay, now again there is something wrong because it's not accurate. The curve is not smooth because the increment here is 1. So let me make it incremented by 0.05 like this. Run the program to show you the result. Still it needs more. Say that 0.05. Run. It's okay, but too much here. Say that it's 0.9. Okay. Say that 0.1 again. Too much. Say that 0.3. You can make zoom in, zoom out, never mind, it's okay. Okay. Now say that I want labels. I will show you how we can okay, say that I want labels. Here we have to say inside this subplot, hold on. Okay, say that this is second plot, this is third plot. Hold on from here to here. I see from here to here, it's the plot in this say area. Plot number 1, figure number 1, we have this plot. Here we have to write as example title. Say that it's title. It is plot for, say that, or K, say that K equal 100 plot as example. I will repeat the same thing, hold. Same thing here. We can write hold before the first plot and repeat the title, Control C, Control V, title of K equal to 300. And same thing for the last plot. So let me say that this is the last plot. Here we have to write hold on, because I'm plotting, and then plotting the title also. Control V the title for K equal 500 plot. Run the program and see the result. See, This is k equal 100 plot, this is k equal 300 plot, this is k equal 500 plot. So in this lecture, we learned how we can deal with polynomials, how we can evaluate polynomial at certain point, how we can find the derivative of that polynomial. We use the polyval and ployder functions, and we learned how we can use the symbolic equations for any function different than polynomial, and how we can find the derivative using the diff function, how we can evaluate this function using the subs, how we can also find the roots, find for any polynomial. We learned how to plot using the plot function, what are the options we can use, how we can plot the title, the x label, y label, how we can keep more than one plot in one figure using hold on. We learned also how we can use the subplot and bar plot also. We reached the end of the video. Thank you so much for watching this video. See you later in next video.